Okay, now let us go to Theorem 7.2. That is nothing but the converse of basic proportionality theorem. Now, this theorem states that if a line DE of a triangle, if a line of a triangle is drawn in such a way that it divides two sides in the same ratio, then that particular line is parallel to the third side. Now, the given condition is that when you consider triangle ABC, DE is a line drawn in such a way that AD divided by DB is equals to AE divided by EC. In other words, this particular line DE divides the sides AB and AC in the same ratio. Now we are asked to prove that this DE is parallel to BC. Now we know that in the previous one, the basic proportionality says that if D is drawn parallel, then it divides the sides proportionally. Now in this case, if it divides the two sides proportionally or in the same ratio, then we're asked to prove that it is parallel to the third side, that is BC. Now to do that, the given condition is AD divided by DB is equals to AE divided by AC. Now to do that, let us try to use basic proportionality theorem. Supposing from D, say let's consider whether D is parallel or not. Suppose let's consider whether if it is not. Suppose you draw a line DF, let's call it DF, in such a way that DF is parallel to BC. This is a construction. Draw DF parallel to BC, intersecting the other sides AC at the point F. Now this is a given condition. Now by basic proportionality theorem, let's call it in short BPT, it says if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same ratio. So by basic proportionality theorem, since DF is drawn parallel to BC, so as a result we get AD divided by DB is equals to AF divided by FC. Let's call it this as equation 2. Now equation 1 is the given condition. Equation 2, that is from the construction, that is DF is drawn parallel to BC. So if we compare equation 1 and equation 2, then we see that both the left hand sides are equal. So as a result, the right hand side has to be equal. So from equation 1 and 2, we'll get AE divided by EC is equals to AF divided by FC. Now if we add 1 on both sides, that is AE divided by EC plus 1 is equals to AF divided by FC plus 1. You take the LCM, so that is EC, AE plus EC is equals to FC, AF plus FC, or implies AE plus EC. AE plus EC is nothing but AC divided by EC. Same thing on the right hand side. AF plus FC is nothing but AC divided by FC. Since AC and AC are equal, so the denominator has to be equal. That is EC is equals to FC. Now, since EC and FC, that is EC and FC, they are on the same line, that is on the same side, AC. So what does it mean is that if your CE, now EC can be called as CE, can be read as CE as well. So if your CE is equals to CF, which are on the same line, then automatically it follows that this E and F coincide. In other words, E and F are nothing but the same point. So as a result, E and F becomes the same point, that is at the same point E. Now, since DF, by construction, DF is drawn parallel to BC and E and F they are nothing but the same line, so DE is parallel to BC, which proves the theorem. So let me remind again, if a line is drawn in such a way that it divides the intersecting sides in the same ratio, then that particular line is parallel to the third side. Thank you very much. I hope you are staying safe, staying home and staying safe.